Let us discuss few types of matrices. First, an idempotent matrix. A square matrix A is said to be an idempotent if A square is equals to A. You can observe an example. Properties of idempotent matrix. A and B are idempotent, then AB is an idempotent matrix if and only if AB equals to BA. If A and B are idempotent matrices, then A plus B is also an idempotent if and only if AB equals to BA equals to a zero matrix. A is an idempotent, then and A plus B equals to I, then B is also an idempotent matrix and AB equals to BA equals to a zero matrix. The diagonal matrix 1 1 1 so on is an idempotent matrix which you get like this. For an example of order 3, we get like this, which is an identity matrix which is denoted with the letter I. As we know, I square will be always I. So I is an idempotent matrix, we can say. If AB equals to A and BA equals to B, then we can conclude that A square equals to A and B square equals to B, which is very important property. Next type of matrix, involutory matrix. Matrix A is said to be involutory if A square equals to I. Next type of matrix, involutory matrix. A square matrix A is said to be involutory if A square equals to I, where I is an identity matrix. Can observe an example. Next type of matrix, nilpotent matrix. A square matrix A is said to be nilpotent if A power n is equals to 0, where n is any natural number. So the least positive integer n is called as index of that nilpotent matrix. See an example. For this example, A cube is equals to a 0 matrix we get, hence the given matrix is nilpotent of index 3. Next type of matrix, conjugate of a matrix. The matrix obtained by replacing the elements of it by the corresponding conjugate complex numbers is called conjugate of the matrix A. It is denoted by A bar. You can observe an example. A is equals to a matrix of order 3 by 3. A bar will be the matrix obtained by replacing the conjugates. 1's conjugate is 1, 2 minus 3i conjugate is 2 plus 3i, and so on. Next, properties of conjugate of a matrix. A is any matrix, then A bar whole bar will be A itself. A and B are two matrices of same order, then A plus B whole bar is equals to A bar plus B bar. Let A be n by n matrix and B be n by P matrix. Then matrix multiplication is defined. Then AB whole bar will be A bar into B bar. A be any matrix and K be any scalar, then Ka whole bar will be K times of A bar. A be any matrix, A power n whole bar will be A bar whole power n. Next, transposed conjugate of a matrix. Transpose of a conjugate matrix is called transposed conjugate, which is denoted by A power theta. So look at an example. A is a matrix of order 3 by 3, then A power theta is obtained by taking the transpose of the conjugate matrix. Let us see few properties of transposed conjugate of a matrix. A power theta whole power theta is A plus B whole power theta is A power theta plus B power theta. Ka whole power theta is K bar of A power theta, where K is any number. AB whole power theta is B power theta A power theta. A power n whole power theta is A power theta whole power n. Next, Hermitian matrix. If A power theta equals to A, then the matrix is said to be Hermitian. You can see an example. Properties of Hermitian matrix. A is Hermitian, then Ka is also Hermitian, where K is any real number K, and A power theta theta A are also Hermitian matrices. If A and B are two Hermitian matrices, then AB is also Hermitian if AB equals to BA. If A is Hermitian, then A bar is also Hermitian. A is a square matrix, then A plus A power theta is always a Hermitian matrix. And any square matrix can be uniquely expressed as A plus IB, where A and B are Hermitian matrices. Next, skew Hermitian matrix. If A power theta equals to minus A, then the matrix is said to be skew Hermitian matrix. You can see an example of a skew Hermitian matrix. The elements of principal diagonal are zeros and the other elements are symmetric about the principal diagonal and numerically equal and having. Next, skew Hermitian matrix. If A power theta equals to minus A, then the matrix is said to be skew Hermitian matrix. See an example. Next, properties of skew Hermitian matrix. If A is skew Hermitian, then Ka is also skew Hermitian, where K is any real number. If A is any square matrix, then A minus A power theta is a skew Hermitian matrix. A is skew Hermitian, then IA is Hermitian matrix. A is skew Hermitian, then A bar is also skew Hermitian matrix. A and B are any two Hermitian matrices of same order, then AB minus BA is a skew Hermitian matrix. And every square matrix can be uniquely expressed as the sum of Hermitian and skew Hermitian matrix. Next, orthogonal matrix. A square matrix A is said to be orthogonal if A transpose equals to A transpose A equals to I. See an example. Properties of orthogonal matrix. If A is orthogonal, A transpose is also orthogonal. For any two orthogonal matrices A and B, AB is an orthogonal matrix and BA is also an orthogonal matrix. If A is orthogonal, then A inverse is an orthogonal matrix. Next, unitary matrix. If A power theta equals to A power theta A equals to I, then the matrix A is called unitary matrix. Properties. If A is unitary, A transpose is also unitary. If A is unitary matrix, A inverse is also unitary. For any two A and B unitary matrices, AB is also unitary matrix. Let us see an example. Given a matrix of order 2 by 2 is unitary, then we need to find the value of A. Let us see the solution. Given matrix is unitary, so A power theta will be equals to I. So multiplying A and A power theta, equating it to identity matrix, on simplification we get A is equals to minus 1. Next example. A is a matrix ABC, BCA, CAB, and given ABC equals to 1, the product ABC equals to 1, and A is an orthogonal matrix, then the value of AQ plus BQ plus CQ. Look at the options. The right answer is 2 or 4. Let us see the solution. Given matrix A is orthogonal, so as per definition, A transpose equals to I. So multiplying A and A transpose, equating it to I, we get the values A square plus B square plus C square equals to 1 and AB plus BC plus CA equals to 0, and given ABC equals to 1. So based on these three terms, we can find out A cube plus B cube plus C cube using the relation A cube plus B cube plus C cube minus 3ABC equals to A plus B plus C into A square plus B square plus C square minus AB plus BC plus CA. Hence, A cube plus B cube plus C cube is equals to 2 or 4.